So we also talked about it previously that phase of a simplicity complex is a subset of that complex, right? So if we are given this simplex v0 and v1, so how will you denote it? You will write it mathematically by v0 v1. So this is an example of one simplex, and let's say uh, sigma is the denotation for this simplex. So sigma is, let's call this simplex sigma. So to get the zeroth phase, so sigma I denotes ith phase of your simplex sigma. So sigma is my simplex and sigma minus I is the ith phase of my simplex. So if we follow this notion, then let's calculate for this particular simplex phases. Let's calculate the zeroth phase of this v0 v1 simplex. So here sigma is v0 v1. For this simplex I need to compute the zeroth phase. So sigma minus I is nothing but you have all the vertices from z v0 then vi till vk in your simplex. Just delete this ith vertex. If you delete this ith vertex, whatever you get is that ith phase of my simplex. So v0 v1, if I want to get the zeroth phase, I just need to delete this zeroth vertex and I'll get v1 only, right? So visually how can I see it? It is just a point v1, right? So this point v1 is of zeroth phase of this particular simplex. This point v1 is a phase of this edge v0 v1. Similarly, the first phase, for that we have to just delete this first vertex and we are left with v0. So this vertex v0, this is simply a single dot v0, is also a phase of this sigma and this is my first phase. So this is how I can compute all the phases. Just keep on deleting one by one each vertex and whatever you get is that ith phase of your simplex. Let us see it for an example of two simplex. So here my sigma is v0 v1 v2. So how you can visualize this v0 v1 v2? You can do something like this. Here you have v0, you have v1 v2, you have an edge here, and this triangle is filled. This is my v0 v1 v2 simplex. Let's compute the zeroth phase. For zeroth phase I just need to delete this zeroth vertex and this is I am left with v1 v2. So v1 v2 is zeroth phase, and if you visualize it, the picture will be something like this. It will be an edge v1 v2. Similarly, the first phase will be, we'll delete the 1th vertex. I am left with v0 v2, and second phase will be v0 v1, and this will be again an edge from V0 to V2, and this will also an edge from V0 to V1. So you can see here that for this whole simplex, this V1 V2 is my 0th phase. This V0 V2 is my first phase, and this V0 V1 is my second phase. 0th phase, first phase and second phase. So for this triangle, faces are edges, and for this edge, faces were vertices. Similarly, if we go for 3 simplex tetrahedron, those uh, triangles we have will become the face of my 3 simplex. So you can keep on increasing the dimensions. So as much as vertex you have, just delete one vertex, and whatever you are left with, that will be your face. And one thing you can notice here is that, let's say dimension of your sigma is n, then dimension of your dimension of a face, that is sigma minus I, will be n minus 1. So when you compute face, the dimension get reduced by 1. So here you can see that when we have 1D simplex, the face were of 0 simplex. When I had 2 simplex, this triangle, face were of 1 simplex, of 1 dimension.